So it's actually at the start of my career, I was doing COBOL, not some point. So I was just joking with the MC that maybe I should just switch the topic to talk about the merits of COBOL programming and the least complexity we deal with in the past, right? Platform engineering has been quite a topic. For those who don't know, platform engineering has been quite a topic in the last maybe 12 to 18 months. But the question to ask is, what is platform engineering? The funny thing about our industry is always this, right? We have this tendency to kind of rush into the solution, right? Find that magic pill to a problem, right? And in the context of platform engineering, I often hear questions about, oh, you know what are the products that defines platform engineering? Is it Backstage? Is it Pod? No. Where does everything fit on Gartner's magic quadrant? And it's the same thing with DevOps, right? I remember once one of those pointy hair manager, if you're a fan of Gilbert, came to me and said, Pan Yong, we needed DevOps. And I was thinking at the back of my mind, I say, wait, you don't even have a developer team, right? And DevOps is about culture, and how do you build culture with no team? And it did occur to me after some time, what he really wanted was, he wanted to buy the tools. And of course, you can buy all the tools, right? If you have money, you can buy all the tools you want. But the fundamental question to ask is, upon purchasing the tools, are your problems solved? In fact, do you know what the problem you're trying to solve in the first place? So today's talks, I hope I can share with you HDX experience of doing platform engineering, but still learning in the process, and also to share with you the why we're doing it and how we're doing platform engineering. For those, oh, that's my slide, there you go. For those who, that's the agenda today. So there's 10 slides I'm going to share with you. If you're counting down your time, you can do it with 10 fingers to do that, right? So Prologue, who we are as HDX. So we're quite a new agency, it's a government agency. We are essentially the tech arm for the folks in the immigration, ICA, the policemen, and the civil defense, the paramedics, the first responders. So we're essentially the tech arm, right? We provide the services to our agencies, and we kind of outsource all the infra built to our vendor, right? The infra vendor, move your app vendor, deploy in the cloud, and voila, we are on cloud. So we're going to go off to tell the world, right? The government has transformed to a cloud, we have modernized our application, and come to a conference like that and pat ourselves on the back and say, yeah, no, we're the most modern government in the world, right? There's a joke behind it, but anyway, I hope some of you caught it. And we even have DevOps, right? We included the security folks, the post-security folks, the picture, and we tell the whole world we're doing very well. But the reality is kind of different, right? It's far from what we imagined, right? So what we did, all these pictures are generated from Midjourney. So the reality is this. Our as vendors still takes about 6 to 9 months to onboard the application, right? It's true, someone can contest that. And the funny thing is we realized even as we do DevOps, there was actually this guy called the CI/CD guy. Anybody remember release management or still doing release management, right? There's this release manager. So the guy basically just say, I'm no more release manager, I'm the DevOps manager, right? So the developers don't check in software, they go to this guy, and this guy take care of pushing the software into the environment. And then we have an infra vendor. They love to guard the house. They felt that this is my house, and make sure nothing comes in, neither people nor the software, right? So that was the kind of situation we're in. And as a customer, we kind of look at the whole situation, ask our question, right? That's not really DevOps, right? We have gone to a cloud. We are not faster than on-prem. In fact, our costs have gone through the roof. Right, we are spending much more in terms of cloud because I think people are not really taking care of spend because you can spin things off anytime. It's okay to write bad software. So that's really the problem we are facing today. We are not getting the ROI for the investment we're making. And these are actually taxpayers' money. We're quite mindful of that. But the point I'm trying to make here is this is not a dig of anybody in the chain. It's not a dig. The real issue we face today is DevOps is hard. It's really hard. It's even harder when the teams doing the delivery are suppliers, right? DevOps building culture. How do you pull the likes of vendor A, wouldn't name names, and vendor B come together? Let's be hunky-dory, kumbaya, work as a team, right? We're all going to love each other. Not going to happen, right? DevOps is really hard. The other reality is the cognitive load of building software in the cloud is really difficult, right? Those who are old enough to remember COBOL, I saw some gray hair, right? So please don't pretend you don't know what's COBOL. Those who are old enough to remember that on-prem, we used to have the firewall guy, the load balancer guy, load balancer guy, the database guy, the sysambient guy, and then in today's world, we say, look, we're going to compress all these guys together. You are the DevOps engineer. And by the way, please write some software as well, right? It's hard. So the cognitive load on developers is really, really difficult, right? So these are the reality we kind of face in our environment. So what's our appeal, right? Going back to the pointy hair manager, right? So pointy hair manager love gardeners and see how everything fits. So as someone is enlightened enough and long enough the career, I better speak the same lingo. So this is my 2x2 BS. BS stands for business school, for those who get it wrong. So we kind of look at, say, we want to do platform engineering, and that's the 2x2 matrix. And that's real, it is not kind of BS, right? We kind of look at two important metrics, right? In terms of developer centricity, is it built for developers' experience, or is it really designed for administrators? That's kind of what we see at it on the vertical axis. And the other axis across the horizontal axis, we look at two things. Is it highly abstracted from the developers, right? Or is it high adaptability, right? So maybe I'll give you some examples to give a sense of it, right? So we're all familiar with CSP portal, Cloud Service Provider portal, AWS, Azure, GCP, whatnots, right? They're kind of sit in this space called high adaptability, right? You can go in and configure your VPC, right? Change your storage, do whatever and do with the resource group, do your tagging and whatnot, right? So that's kind of really highly adaptive, but they're still very much designed for administrator, right? Administrator understand the concept of networking, of load balancing, or routing, a whole bunch of stuff. This kind of fall in that space, right? The other space, the other area is some have seen some of this product before, right? Hopefully they're not out in the booth, but just in case they're out there, this is a space called the Cloud Management Portal. They're designed for traditional system administrator. They're very administrator-centric. It's kind of abstracted. You say, look, I want to deploy Nginx server, bang, right? You can just click a button, off you go. But because it's so abstracted, sometimes it's quite difficult to make changes, right? That's the challenge with abstraction. It's easy for simple stuff, really, really difficult when do different stuff, right? And then at this quadrant, that's where some of this conversation about backstage and pod is happening, is the IDP space, right? Internal Developer Portal space. They're kind of developer-centric, because you almost speak the lingo about application, services, and stuff like that, but this still kind of fall into this extraction space, right? You can make certain level of changes, but at one point in time, say I want to deploy a different kind of network as the underlying infrastructure, it becomes slightly more difficult. It requires you to sort of fix your network design in those spaces. So where we kind of land for ourselves, again, it's a learning journey for us. This is not the Bible. We kind of say, look, maybe there is a space where it's high adaptable and developer-centric. And we kind of landed on this about what does the developer like to use, right? What makes sense for developers, right? And the answer comes in the next slide, how we see CDP, right? So the approach we are taking is, can we, from a developer experience-centric, can we keep them within the flow? Can developers stay within the flow? So example, right, if I'm coding some stuff, do I need to pause halfway and say, jump off the portal and say, by the way, I'm going to deploy this thing, come back here and do it again, or I'm going to write a whole bunch of stuff on maybe Node.js, then stop, pause, jump off to Lambda, deploy some stuff Lambda. For those who doesn't know Lambda, serverless on AWS, that kind of breaks the flow for developers. So our approach we want to take is, can we keep them in the flow? Developer uses VS Code, continue in VS Code, right? They use SQL ORM to map databases, continue to do that. If it's just coding environment variables, right? That means all I need to know is this is a variable, secrets, variable URL, right? Can we be just talking to variables and not worry about there's something specific in the cloud? They work with Docker, kubectl, automate testing, and Git. Can we stick that kind of experience? So you sort of get the flow I'm coming from, right? Keep developer within that flow, and they kind of push out code, whether it's cloud on-prem, the same behavior. Working with Git, working with VS Code, keep the same tools that they're doing. So we're not embedding new tools, right? Stay within the flow, right? And how do we kind of achieve that? We came up with this concept called ORCA, is what our cloud delivery platform. ORCA stands for Orchestrate Developer Flow. Government like acronyms, so I have to figure out an acronym to make sure my bosses understand I'm doing real work. So we kind of break down CDP, as the term we use it, into really 1, 2, 3, 4, 5. Can I count 1, 2, 3, 4, 5? Yeah, 5 planes, right? I'll kind of develop 5 planes. I won't elaborate. The developer plane is really about what does the developer need, right? Focus about their user experience, developer experience, exactly what they need. And then there's kind of a catalog plane. I'm going to spend a bit more time. On the catalog plane. It's really about how do you scaffold your IAC, right? At the foundation level of the IAC is what we call landing zone. If you need a landing zone for microservices, how would that kind of look like? But most of the time, beside the base, you needed services on top. This is what we call solution accelerator, right? I.e., maybe you want to plug in. We still have VMs, unfortunately, right? In our world, unlike Trust Bank, we're so happy that you're fully on container. So we have to deal with the VM stuff. Somebody may need a file transfer server, whatnot, right? So can those be plugged in as a solution accelerator? And then policy of code is the principle of us governing consistency in IAC. So that's really where one part of our catalog plane is about doing our IAC properly. Again, because we're at VM, and HashiCorp still offer Packer, of course we'll continue to do that. And then we say, how do we do image factory for all the projects so that developers does not have to worry about it. And the underlying some of this concept is really what we call golden path and good defaults, right? Golden path, for those who are not familiar with terminology, is really about, can I create a path that's right, that will always work for developers, right? Almost giving you the same experience of DigitalOcean or Heroku. Deploy the app, by default, most of the companies working. If you're doing Node.js, you need an ingress controller, you're doing Python, we actually build a path for you, right? You do not need to think about other things. So that's really the underlying design of our catalog plane. And then and we have code generation software as well as part of catalog plane. The other two planes, the other plane I want to focus on is really integration delivery, right? That's really the so-called the magic in the whole chain. How do we pre-build CI/CD pipeline? How do we pre-build the tooling? We mentioned a bit about security within the pipeline, whether is it container scan, whether is it Kubernetes scan, whether is it automated testing, static code analysis. How do we pre-build the pipeline for project? When they come aboard, off they go in terms of application cloud. And then we have the resources and the delivery platform. I try to figure out, is the clock counting down or counting up? Well, it's counting down. It's 6 minutes left. There you go. I'm going to speed up a little bit. So I will elaborate on the developer plane, right? I will just quickly summarize as a few key approaches, right? When a project gets launched, each project, when they get launched, basically give them 3 things, 3 repositories, right? IC repository, of course, that's on Terraform, right? Thanks HashiCorp. That's on Terraform. We pre-provision a K8 infrastructure, right? That comes with an ingress controller, comes with all the necessary security controls, and we have the app example of an application that have a pre-built CI/CD pipeline, right? All the developers need to worry about is how do I change my container? What is the resource path for my services? Really keep them within that so-called that MySpace when they push software out. So that's really the developer plane. One thing we learned. We talk about DevOps as a culture. One of the biggest challenge about infrastructure engineers or ops folks is they don't understand the dev people, right? Somehow they come from different world. One thing I got the team to do is really, in order for you to write services for your customer, with your developers, you got to know how to build apps yourself, right? So we got a team to build what we call test-flight application that does really essentially 3 things, right? Number 1, it provides a golden path on say, look, this is exactly how we deploy an application into a cloud on top of Kubernetes, right? It can't extract away all the interfaces to a cloud, whether is it connecting to databases, doing API call, connecting to storage account. Instead of calling cloud native API, we sort of extract the API call for them. So as far as concerned, again, developer flow, all they need to do is work with environment variables, work with ORM, and bang, off you go, and connect to the cloud environment. So there's some picture on the left, is really about pulling in config map and secrets, mounting into the environment itself, right? So essentially, the app also acts as a test environment. A lot of times when people deploy SAP in the cloud, you don't know whether it's going to work or not, right? So we use the same test flight app. It's a fast API application that also provides automated testing capability to test all the interfaces and integration to the cloud as well, right? So that's the other part of the component. I won't spend too much time on the resource plane, but essentially, I think earlier that some of the discussion about security is really essential. We can talk a bit more during the fireside chat. A few things we kind of think about is what are the stuff that we can sort of centralize on top in terms of internet-facing services? What are the areas to manage centrally in terms of parameters? And at the middle of it, essentially look, how can I have a micro-segment isolated zone that can sort of reduce the blast radius when things happen, right? It's kind of a bad idea, at least in our context, to share Kubernetes cluster. There's still a lot of unknowns. People can screw up quite easily, and we kind of want to keep things within blast radius. That's how we kind of approach it. I kind of like what Trustman shared about chaos engineering. That's quite critical. I think moving forward, from a security standpoint, how can we use more data, right? It's really key to manage our environment. So moving all data into a cloud become quite essential. I spoke a lot about Golden Path earlier, but I just want to highlight one more thing is the approach of security starts to change the cloud, right? It's no more a discrete step of security, but a continuous security posture management, right? How do you ensure that you can do vulnerability scan all the time? Can you continue to protect your secrets? Again, maybe I'll do a plug for HashiCorp board in that context as well. Our approach for cloud is really what we call the Kubernetes Native is the new cloud native, right? Next. Second last slide, in case you're counting down, you should be on your ninth finger at this point in time. K-native for us is really the new cloud native to allow us to do multi-cloud portability, right? That's quite essential. But the fact is, it's tough. You can get it wrong very, very quickly, very, very easily. So a few things team got to understand quite clearly is in the space of cloud, whether it's EKS, is it AKS, or some strange Fargate running on EKS, which I don't understand, is about a shared responsibility model, right? There's some parts the CSP do, some parts the platform team does, and some parts the developers got to figure out themselves. And a lot of this require us to provide really, really good golden path for Kubernetes. A few things we've done is really, when the cluster gets spin off, we have pre-built the container scan in the CI/CD pipeline. We included, in this case, this is Azure example, included Defender for container security, right? And we provide a hardened ingress controller. We sort of force people to use a pre-provisioned ingress controller and sort of harden the ingress controller. Each of our Kubernetes deployment, as we deploy it, becomes a secure manifest. We ensure there's port security admission, make sure that only the right ports can be spinning off and doing work. Apply network security. That's quite a big problem for us, how to ensure that only certain ports can have an egress out to the internet and certain doesn't. Pre-provision that. Ensure that there is workload identity, that only certain workload can access the secret, access the database, access the shower account, and pre-provision that. You can't get the developers to understand that. And other things around making sure that we pre-provision AppArmor and SEPE around what the resource path or what a file can access, as well as what kernel API call that it can make. And then overarching it is to apply policy as code, make sure that things stay hunky-dory along the way. So got 1 minute left. I want to get a sip and before I close it off. Given this is a strategy session, I'll just talk a bit about the strategy we take towards the cloud. My sharing is strategy operates in context. We have very different contexts to operate. Many of you come from a different background. You have a different context to operate. Our focus is really how do we give a cloud agnostic developer experience. Can they don't bother about where's the software going out to? In our experience, you got to build out a platform engineering team. It's not easy, but it's hard work as well as SRE team as well. A lot of discussion in the cloud is about lock-in and what does it mean. I didn't go to weigh the benefit, right? The question, I'm not expert in the space. Go read up Gregor Hope. Sam Newman is perfect on the space. if you're a fan of them, but it's really well the balance, right? I think not to look at it from a cloud provider perspective, but look at services, right? VMs, low lock-in. EKS, AKS, low lock-in, low cost migration, right? Once you go serverless, hard question to ask, right? Do you want to get locked in to Lambda, locked into some other services? It's a question that each of you have to weigh out the benefit, and we make those decisions ourselves. We are betting on Kubernetes Native. I'm not sure what's the own bet, but that's kind of where we're going to. There's some question to talk about hybrid cloud earlier. We kind of believe in connected cloud instead of hybrid cloud, and what's the main difference? The difference is this. If you think about hybrid, it's really about you have a kind of unified management across the different clouds. We can say, let's scale that down. We recognize that cloud will be connected, Azure will connect to AWS, and some of them will connect to on-prem, but we not go the full length trying to unify the management, like some people peddling their unified management software. I won't name names, but that's not HashiCorp, but so bear in mind, and make your own decision. For the Singapore government, the big challenge we have is about data residency. We have to put data in Singapore and nowhere else. But that impacts our thinking around multi-cloud. So think about it, right? Azure went down some point last year, I can't remember when. But the lesson learned from experience is when that go down, we can't pay over to Hong Kong or Malaysia or USA, right? We're not big enough as a country. The only option when there's a prolonged outage, you really fail over to another cloud service provider. So there's some of this context really govern our decision. And last of all, before I close off, as you think about strategy, I think about approach, don't be religious about it. Things are going to change, and it's about how do we adapt to the changing landscape in the cloud and that's our goal. If not, thank you very much, and hope it's a useful sharing for everyone. Yeah.